Welcome back, Pre-Algebra. We are in lesson 49, and we're going to talk about surface area. Surface area, in order to have surface area, you need to have some object, right? Something that has a surface. And it's a lot easier to define surface area of flat-sided shapes. So here I have a rectangular prism, and a rectangular prism it's another way of saying a rectangular box with every angle measuring 90 degrees. That is the definition of the prism. The definition is literally that the top is directly centered over the bottom. That's what that means. So in order to do that, your lines have to be perpendicular, which means that every angle is 90 degrees. So in this rectangular prism, or I should say outside of this rectangular prism, there's a certain amount of surface area. And we find surface area by calculating the area of each face of the shape. So in order to do that, we have to first understand what the faces of this shape are. So that is defined by its net. This is the net of that box. So in this box, you see we have a base here on the bottom, right? That is the base here. Connected to that along this fold right here, this fold line, we have this end, this square. This is the right side of that box. All right, so that's this right here. This is the right. This is that whole section, and it's connected along this line connecting to the base. Now on the other side, we have the same thing. We have the left end of this box, and that would be the left side of the base. Now what's interesting about the left and the right is they are mirror images of each other. Remember how we talk about the look across when we're talking about shapes, where you look across from one side to the other and they are equal? The same is true for prisms. When you have the area of the base here, when you have an area here, and this is a right rectangular prism, you can do the look across, and what is directly across from it is going to have the same dimensions. So the left is going to be equal to the right. So what that means for us mathematically is that when we calculate the left, we can multiply it by 2 so that we can get both areas without having to calculate it twice. But if you want to calculate it twice just to make sure, go for it. So then connected to the back here, let me erase this so it's not in the way. Connected to the back of the base along this little line here, we have the back, right? Or the back face, but this is the back. And the back is going to have the same length as the base right there. It's just folded up. All right, so there is that. Now, the back is opposite what part? I'm going to erase this word here so you can see it. This is the back. But then this, let me get my highlighter, this is the front. So the back, you look across from the back to the front, across from each other. Think about an aquarium, like a fish aquarium. The back is going to be the same size and shape as the front. That's what we kind of have here. We can do the look across and they line up exactly. So the back and the front are going to be the same. So you can find either the back or the front and multiply it by 2 in order to get the surface area for both. Now, let me erase all of this right here. Above the base, or what we call the bottom, you have the top. This is the top right here. You can't see that. Let me use my highlighter. This is the top, and it is directly above the base. So if you were to stand underneath and look up, you would do the look across. the base would be exactly the same shape and size as the top. So that means that the base is equal to the top. So you could find either the base or the top and multiply it by 2 to get the sum of both of those. So this is the net of a rectangular prism. All right, I'm going to erase all of my little notes here so you can just see this better. So you have the left and the right, the back and the front, and the base and the top. And they are paired up because they are identical. So the way we want to find the surface area, think of it as the amount of wrapping paper we would have to cover this box, right? We can write this formula for a right rectangular prism as 2 times either the left or the right. Let's just say the left. And then add that to 2 times the back. Plus 2 times the base. That's going to be the same thing as saying the left plus the right plus the back plus the front plus the base plus the top, because these are all exactly mirror images of each other, so they have the same value. So we can just say 2 times one of them. It's the same formula. What I'm trying to get you to do is to wrap your head around the components of this shape so that you can see their value and you can see how you can help yourself solve this more efficiently. Okay, so let's do this first of all the hard way. If the length of this box is 3 meters and the width is 3 meters, I'm sorry, this cannot be 3 meters if this is 3 meters. So let's say this is 4 meters. 4 meters, and the width is 2 meters. And the height, this looks like a square, so let's say the height is also 2 meters, right? We can apply that dimension here. So the width is 4 meters. So that means every single one of these lengths is 4 meters. So the back is going to be 4 meters wide. The base is 4 meters wide. The front is 4 meters wide. And the top is 4 meters wide. Now the width or the depth here is 2 meters. So that means that the base, that's the 2 meter base here. So that means this right side, this is 2 meters. We're going to do the look across. This is going to be 2 meters. These lines here, all of these lines are 2 meters. So that's that dimension all the way across. So now we have the height, and that is going to be this dimension right here. So that means this dimension is 2 meters, but it also means this dimension is 2 meters because when you fold them up, they meet right here on this edge. So this would be 2 meters and this would be 2 meters. That also means when we do the look across that this is 2 meters. That also means that this is 2 meters. And because we have the look across here, this is 2 meters and this is 2 meters, when we fold this up, here's our top, right? This is the front, this is the top. This length right here is the same as this length right here. And this is directly above this. So that means when we do the look across, this is 2 meters as well. So now we have, let's see, we also have, if this is 2 meters, then this is 2 meters. And if this is 2 meters, then this is 2 meters. Because when they fold upwards to form this corner, this is going to be the same as this because of the look across. This lines up. So if this is 2 meters, then this has to be 2 meters as well. Okay, can everybody see that right there, how that works? When you fold this up and you fold this up, it makes the corner. When you fold this flat, this lays down right there, and this one would lay down right there, right? So that's the left, and this is the base or the back. So you can see how that folds together to create this line. When we fold it up, it actually creates that corner. So that is, now that we have all of our dimensions, let's do it the hard way first. So let's find the dimensions of the back. So the back is 4 meters times 2 meters, right? So the back is going to be 4 meters times 2 meters. That's the back. All right, that equals 8 meters squared. Actually, I think I'm going to do is write this to the side. So this is the back. Now let's do the base. The base is going to equal 4 meters times 2 meters. So again, 4 meters times 2 meters equals 8 meters squared. Now let's do the front. The front is the same dimension, 4 meters times 2 meters. That equals 8 meters squared. Now I can do the top, and the top is 4 meters times 2 meters, and that equals 8 meters squared. All right, so we got the back, the base, the front, and the top. So let's do the left. And the left is 2 meters times 2 meters. So that's going to be 4 meters squared. And the right is the same dimension, and it's 2 meters by 2 meters. 2 by 2, and that's going to be 4 meters squared also. Meter square is all the same, so we can just write it down. And we have 8, 16, 24, 32, 36, 40. 40 meters square is the surface area for this right rectangular prism. I really believe that if you practice making the net for this shape, it will help you find the dimensions, okay? But there's a faster way. And the faster way is through understanding what those shapes actually are, and understanding how they equal one another. So we said the left and the right are the same, and when we look, we see the 2 by 2, 2 by 2. So we know they're the same. The left and the right equal. So we can say the left and the right is equal to 2 times whatever the dimensions are, and that was 2 meters by 2 meters. Okay, that's going to be 2 times 2 is 4 times 2, that's going to be 8 meters square. Now we can do the back and the front. The back and the front, there's 2 of those, and the back and the front both have 4 by 2, 4 by 2, right? So 4 meters by 2 meters, right? And 4 times 2 is 8 times 2, that's 16 meters square. And then the base and the top, there's 2 of those, and they have the same dimension, 4 by 2. 4 meters by 2 meters is equal to 16, because it's exactly the same as this, 16 meters square. Now that's not always the case. The only reason that all of these were the same was because the length was the same as the height. If this had been 3, then we would have had different dimensions, and that is why we break down and we just do those shapes that look across from one another, and we'll do that next. So now we can add all of our areas together. 8 plus 6 is 14, plus 6 is 20. 0, carry the 2, 2 plus 1 is 40 meters square. Got the same answer with less effort. So it's very important that you learn how to do the look across. It's going to save you some time. It's going to save you some effort. And understanding how these shapes are put together is going to be important. Now, if we were to do a cube, let's look at a cube. A cube, let me pull one up for us so we can look at it. Let me find, where's my cube at? Here's a cube. A cube is different from other shapes. And the reason a cube is different is because it's based off of a square. And a square has exactly the same dimensions at every side. So 2 by 2 by 2. So that means the net is going to look something like this. If I can do it correctly. Well, not exactly like that. That could be a whole lot better. Let me see if I can make that look better here. All right, that's a little better. So our net is going to be something like every dimension, every line is 2. So this would be 2, 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 this would be 2. Everything is 2. So if all the shapes are 2 by 2, we'd have 1, 2, 3, 4, 5, 6. So for a cube surface area, all of the sides are exactly the same. So we would have 6 times the length times the width. And that would equal the total surface area of the cube, because everything is a square. Let me show you. Let me pull that picture because I can't do it justice just by drawing it. Let me find the net for that. This is the net of a cube. So with this, we can see, we can literally see that every dimension is the same. This is 2 by 2, 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 and this is 2 by 2, which we all know this is 4. So this would be 4, 4, 4, 4, 4, 4, right? So it'd be 6 times 2 by 2. 6 times 4 is 24. That's much easier. So if you have a cube, then you know that each one of these is identical, all right? If you have 3 dimensions that are the same, it's super, super easy to find the total surface area. You just say 6 times the length times the width, right? That's for a cube. But you can always treat it the same way as a rectangle. Learning how to use the rectangle method is always right. You can never go wrong if you treat everything like a rectangle. So you have the top and the base, the front and the back, and the left and right that are always going to be the same in any type of rectangular prism. So that would be 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2. Well, that's going to be 8, that's going to be 8, and that's going to be 8. You're still going to get 24. You still get the same value. So if you aren't quite sure, use the rectangular method. It's going to give you the same answer. But it's important to understand how to break apart your rectangular shape, your prism shape, into a net in order to create that, that surface area layout that allows you to see all the flat sides that fold up to make that 3-dimensional shape. Let's do some practice problems. We've only got a couple. So here we have, let me, there it goes. Let me pull in a shape for us. let's see what we have here. Let's do, do I have a right? I do not. I wonder why I don't have a right. All right, we'll do this one. I would prefer to have a right triangle, but that's okay. We'll get over it. All right, so the height of this right triangular prism, the height is 4, and this is in centimeters. Let me erase this. This is 4 centimeters tall, and the base is 3 centimeters. Now this slope right here is 5, okay? This slope is 5 centimeters, and this length here is 6 centimeters. The slope on this side is also 5 centimeters. Actually, I take that back. This is going to be 6 centimeters. All right, so we have a 6 centimeter base, a height of 4 centimeters, and a slope of 5 centimeters, and then that triangle is 6 centimeters long. Now this is an isosceles triangle because both of these are the same length, right? It really doesn't matter. What we have to do is figure out the net of this shape. So let's do that now. So we have, I always like to start with the base. Here's the base. And the base of this, we see here, this is 6, this is the front. So this is 6 meters. Actually, it's a cube now that I look at it, because we have 6 centimeters. I'm still like writing all kind of stuff that's wrong. 6 centimeters for the length, and 6 centimeters for the front. This is the front right here. And I'm going to take this triangle and I'm going to lay it down. Right here, this is my fold line. So I folded that front down. So I have, this is my height, and it is 4 centimeters right there. And this is my base, and it is 6 centimeters. This is centimeters. Okay, so I have my base and my height. And the other side of the triangle, this is my right, this is my base, this is my left, and it's the same. I have a height of 4 centimeters with a base of 6 centimeters. So you can see how I kind of laid that out. I just laid it out flat like that, and I laid this one out flat like that, just folded it down. So there's my net. So now I have a rectangle here on this side of there's my base, and this is where it connects right here on this line. So I'm going to fold this down, and it makes a rectangle. And my baseline is 6 centimeters here. That's the fold. That's this line right here. And then this slanty line right here, that's the side of my rectangle, and it's 5 centimeters, right? And this is my front. And then my back is a mirror image. If you do the look across, because this is an isosceles triangle, this side is going to be congruent to this side, which means that these two sides are going to be the same. So that means that this, my back, is going to be 6 centimeters wide and 5 centimeters tall. So now I have the net of my shape. This is my left. And I have to decide which two things, or are there any things that I can duplicate in here? Are there any things that are exactly alike? Well, yes, my left is equal to my right. Okay, so I can say, instead of saying that, My left is equal to my right. So my left and my right are the same. So I can say 2 times whatever that dimension is. Well, my left and my right are going to be triangles. So I need to do base times height, and the base is 6 centimeters. And the height is 4 centimeters. That's centimeters. Divided by 2. Okay, that's my left and my right. 6 times 4 is 24, divided by 2 is 12 centimeters square, times 2, that's going to equal 24 centimeters square. All right, so now my front and my back are identical. They're 6 by 5, 6 by 5. So my front and my back on this triangular right prism is going to be 2 of the same shape, and they are 6 centimeters by 5. Actually, they're rectangles, so there is no division. So it's 6 centimeters times 5 centimeters because they are rectangles. This was a triangle, and these are rectangles. So that's my clue as to what my formula is. So 6 times 5 is 30. I have 2 times 30. That equals 60 centimeters square. Okay, that's my left and my right, my front and my back. So it's left and right, front and back. So now all I have is my base. My base is a rectangle, so I only have one of those, and it's 6 centimeters times 6 centimeters. And that equals 36 centimeters square. Centimeters square, I can bring that down. Now 4 and 6 are 10, carry the 1, and that is going to be 3, 9, 12. 120 centimeters is my total surface area for this right rectangular prism. Remember, it's not volume, it's just the external area. So we, just think of it in terms of knowing exactly how much wrapping paper we're going to need. Okay, so making the net of your shape is very important to understanding how you can do these calculations not only correctly, but efficiently and quickly, right? You know which ones you can put together and multiply because those are the ones that are going to be identical in dimension, right? We have one more. Let's do one more. This was 49.1 in case you want to write that number down for this. And I highly recommend copying the nets and everything. Let's do 49.2. All right, 49.2 is a box. Now, why they didn't give us the box first, I will never know. So let's do the rectangle. All right, so here is a rectangle. You can see now where I get all my shapes from, right? And I am going to pull the net for this already drawn. Actually, no, I'm not. I'm going to show you how to draw it. We're going to do this one again. All right, so we have a base. And let me put in our dimensions. All right, so we have, this is 2 tall. This is 3 wide. And these are meters. And then this is 4 long right here. All right, so I'm going to do the base. This is the bottom part, the base. And it is 4 meters right here. And this is 3 meters right here. So that's this bottom part right here. I'm going to do the back part now. So the back part is here. This is the back. And because of the look across, that means if this is 4 meters, this is 4 meters. So this is 4 meters. So 4 meters. But now the height of this is 2 meters. So that means this is 2 meters right here on the back. Right, so now we're going to do this end right here. And I'm going to do it right here just for the heck of it because I can. So if this is 2 meters here, then that means that this is 2 meters tall. So this is 2 meters, and this is the right side. And then this end right here is going to be 3 meters. Because if you look where you have this corner, these are always going to be the same dimension. Right? That's a clue to let you know that you've paired it up correctly. So I'm going to do the left right across, and the left, if this is 2 meters, the look across tells me that this is 2 meters. And if the look across here, if this is 3 meters, then this edge right here is going to be 3 meters as well. That's the bottom part of the right side. So 3 meters. And we know from the look across here that this is 3 meters as well. So 3 and 3 matches. Okay. So I have the back, I have the left and the right, and I have the base. So now I need to do the front and the top. So the front goes here. This is the line where it folds, right here, it folds up. So this is the length, so it's 4 meters on the front, it's 4 meters wide. And if this is 2 meters, then this is 2 meters, and this is 2 meters. So then it is 2 meters tall, okay? So now I have the front dimensions. Now I need to do the top. So we already know that all of these lines have to add up. So this, or line up. So this is 4 meters wide on the top, because if this is 4 meters, then this is 4 meters and this is 4 meters. So the top is 4 meters long. And if this is 3 meters, then we go up, the top is going to be 3 meters as well. So this is 3 meters right here. So now I have, if I do my look across dimensions, I have my left and my right. That's going to be 2 times, and my left and my right are both 2 by 3, 2 by 3. So 2 meters times 3 meters. 2 times 3 is 6. 6 times 2 is 12. So 12 meters square. Okay. Now I'm going to do my front and my back. There's 2 of those and they're identical. The front is 2 by 4 and the back is 2 by 4. So 2 meters by 4 meters. And that's going to be 2 times 4 is 8. 2 times 8 is 16 meters square. Now I'm going to do my top and my base. There's 2 of those. And my top is 4 by 3 and my base is 4 by 3. So 4 meters times 3 meters. That's going to be 12 meters times 2. That equals 24 meters square. Bring my meter square down. Add them all together. That's 8, 12, it's 2, carry a 1. That's going to be 52 meters squared. And that is the answer you would put into the system. So you see how drawing out the net helps you to see what your surface area is. You really, really need that surface area to be accurate. And in order to do that, you need to draw it out so you can see it. All right, that is all we have for lesson 49. I will see you in lesson 50.